Hello and welcome to today's webinar, Increase Market Share and Profitability with Graph-Based Doctor and Product 360. Today's session will be hosted by Sharat Indapali from Exact Sciences, who will share insights from their application and their success, and Scott Heath from Expero, who will walk through what the application and some insights into the art of the possible. And with that, off to you, Sharat.
Thank you so much for joining me for the summit. I hope everybody is staying safe and healthy with the COVID times, and I'm glad you could join me. And who we are, who is Exact Sciences? We are a leading provider of cancer screening and diagnostic tests, and we relentlessly pursue smarter solutions, providing the clarity to take life-changing action early on. So for this particular purpose, we always keep trying to find latest and greatest technologies to make our life easier and to make sure we are delivering the proper solutions. On to the next slide. This is the standard disclaimer. The statements and opinions that I'm going to share with you today are my own and do not necessarily represent the position of my employer, Exact Sciences, or any of its affiliates. So now that we have that out of the way, let's see what Gartner says about graph. So, as you know, we have to take it with a pinch of salt about things coming from Gartner. It's not a perfect world, but this is what they think. These are the 10 important technology trends, which they think most of the medium to large size companies should start thinking about. So you see, I'm very glad to see that graph analytics fits right over there towards the corner. And I definitely think it's going to be a great technology to have it implemented. So by graph, why do we change now? So business wants to look at the data and ask questions in the ways they haven't done it before, right? They want to blend the data and across different business units, and they also have a need to combine it with our external data and do the analytics like potentials or anything, right? So the questions the business is asking, it's becoming more complicated, and the fast-paced approach of the business is what will help us more in terms of graph analytics. So on to the next slide. So what are we doing over here? We have some of the business cases which we call as customer 360. And what we are trying to do over here is we are trying to see how are we going to track the journey of our customer? How are we going to avoid the churn of our partners and customers? And then how do we get the proper recommendations to avoid it? Is there any potential to cross-sell or upsell? And also, what is the prospect of marketing and analytics? How are we going to do it? Are there any areas where we could improve? Are there best working materials we could tap on? And also come up with apply the algorithms power of graph to come up with a risk and predictive analytics out of it, like turnaround time calculation. And what's the best next action? That is what it really matters, right? At the end, it should be explainable AI. So tell us what is the next best action to be taken? And at the same time, we want to know how we came to that conclusion, don't we all? So that is very much of the business use cases which we are looking at. So your solution needs, and you have augmented it by the ML and analytics over there. So we are looking at a real-time data from the IoT systems coming from to track the real-time performance and predict the outcomes. And then we have the big data, high availability. And then we would definitely be looking at the ML and artificial intelligence to give us some predictive analytics and scoring, and also flag any of the rest. On to the next slide. So what is the business challenge? So the basic business challenge we all run into on a day-to-day basis is how many sources do we have? And how do we bring all the data together in such a way that we do not essentially have to keep implementing the business logic every time we go about doing an analysis, right? We want to put everything together, and at the same time, we would like to explore and see how does this all make sense? What are the connections, and how do we make decisions out of it, right? And the solution we are approaching towards is basically we would want to build something on top of what we currently have and existing infrastructure, leverage it, the data from the Snowflake, and then we would like to be build on top of it by consuming data into our graph databases, organize it in such a way that we could predict and at the same time analyze our customers. And also, this is added functionality of the UI UX functionality for our self-service users as well. So this is what we are looking at as a solution. And the business benefits, its outcome and increase the customer satisfaction. Don't we all look forward to doing that? At the end of the day, all we need is the best customer satisfaction we could provide them. On to the next slide. So what are the current pain points of the customer touch points we have? So we would like to see what is happening around our customer. So how many times have we sent a marketing material? What is the ordering patterns look like? And what are the number of calls we have made? And we would like to streamline all of our customer interactions so that we could make sure that everything can be streamlined and help the customer a properly focused way, right? And we would like to avoid the churn, right? At any cost. We would like our customers to continue ordering with us and be up to date with our studies and our information, which we would like to provide to our physicians. And we would like to see what really worked best in our marketing campaigns, and then intervene and send the ones which really makes a difference, right? So that is all at the end of the day, which matters over here. So there is a potential that we could leverage some of the products and services and make sure the physicians or our customers are aware of our new products and services and how it can change the patient lives, right? What are the products which we are coming up with and how they could make a difference? And then we would definitely like to see a geography-based view to see if a particular territory or a geographic region has high volume of orders compared to a different geography. And we would like to see and know exactly what is happening, right? So the visual impact is definitely something we would like to see out of it, right? So connected data analytics, what we have is products, transactions, actors, locations, marketing devices, and social impact. So that is basically what we are looking at. On the next slide, we're going to see why SQL and graph are very different. So traditionally, we've been very used to storing our databases in our transactional systems and OLAP systems, and it pretty much worked great for storing the information. And every time we have to run an analysis, we literally had to put in a lot of business logic. Like in this particular case, if you're looking at like physicians and what materials are stored, we actually have to put in a bridge table to see what is the mapping between physician and materials. So since we are looking at one-to-many relationships from both the directions, that adds to the complexity. Now, if you're doing a creating a data set for analysis, you pretty much have to do a join over a join again. And it is only always from one perspective. You either start from materials or the physicians. What if I don't know what I'm looking for, but one place is what I'm looking for to explore from any endpoint we have? That is where the graph database comes in, right? It is stored in a way that you can start your analysis from your materials and go to the physician and go to the people connect to that particular physician. And you don't have to write those complex joins and the business logic. And you can do the same from the other side, from physician to materials, and come to the performance of the materials and see what materials could be recommended to other physicians, right? So this is where it actually makes the difference. And now going to this traditional databases, let's see. Now we only have materials, and we also know about the fact that physicians will also have orders. What if I need to run an analysis on what are my materials which are sent to the physician, and how did it impact the ordering pattern of that physician? And especially with the fact that you have one or many materials sent on any particular day to a physician. So then you joining it based on a time series, oh my God, it gets complicated now. So these are the kind of things which were solved with our graph database implementation. Yes, it worked great, and we are still using the traditional database. And this is all to you guys who are fans of traditional databases in SQL. Yes, it works great, and we are still using it. But graph has a different purpose of it, where we actually need to know about the connections and not exactly about how we are storing the data. So that is the difference, guys. So that is why we ended up with the graph database. On to the next slide. So what did we do exactly, right? So this slide, you got to read it from the top, bottom up. So at the bottom of the screen, you actually have a TigerGraph Studio. So what we use it for is for super users to go in there and run some complex algorithms and the complex queries, and also provide some outputs, which we then augmented for the one step above, where we have marketing and sales guys and the customer insights, which is developed on a very interactive web interfaces. So we have it divided by super users and non-super users, because we need to consider that not everybody in a company is very good at coding, right? So TigerGraph, the TG Studio, works very well for our super users. And we have the customer facing, which is our business partners, who are more looking at our self-service, and which we call it as highly interactive web interfaces to get their analytics and customer insights. And you see, our goal is to get to the topmost portion, which is derive centralized analytics for our executives, and provide them with the deep insights as to what is happening around in the company. On to the next slide. So this is a pretty impressive view of how we are looking at things. So this is what we call it as closed loop marketing. So this view, it is pretty simple, but usually this is so complicated to be implemented, right? So at the bottom of the swim lane, we are looking at orders, and then we have different swim lanes depending on our customer touch points and marketing events, like a speaker event, email campaigns, show pad assets. So in the traditional data and analytics, I would say this is very complicated view to be achieved, right? Because you have one or more orders on any particular day, and then you have one or more show pad, which is the marketing assets sent to our customers, and then email campaigns happening in parallel. So bringing everything together in one particular view to see what actually made difference, it really means a lot. So if you're looking at this particular view, it could really mean that whatever we did in 2020 Q3, at the beginning of 2020 Q3, like sending some of the marketing assets and having that email campaign and getting invited to a symposium, it could have potentially triggered an upward trend pattern in the ordering of our customers. So this is where what we are trying to do over here is literally that, to see, put everything together in a perspective and see what really worked or what triggered to help us take it next level of further analysis. Next slide, please. So On this one, so this is the power of graph, right? You get to see all the connections together on a interactive web interfaces or on the TigerGraph Studio as well. So in here, what we are looking at is what is happening around our customer, right? It could be number of orders, or it could be related to the parent company of the organization, and then go about drill down into specific details as to what is happening around each of the orders we have received from the physician, and then get down to the details of the predictive analytics, right? As to what exactly worked. And if you see on the top right-hand corner, you see those little blue and red buttons. Those are the indicators, and you could pretty much be getting your predictive analytics inputting into those indicators, and which gives us visual clues as to what are the areas we might want to investigate more. If, let's say, for a particular account, if the time takes for delivering an order is unusually high, you might want to go down and see what are the reasons impacting it, right? And that is what helps us getting to the bottom of the issues we have. On to the next slide, we will be looking at the same view, same data, but in a different perspective. Now we are looking at things in more of a geographical perspective, geo-based view, right? We would like to see what really worked across different regions, right? We're going to go region by region, and we have a cluster of our customers versus individual customers. So this also provides us the flexibility to actually drill down or scroll over, zoom in on our cluster of customers and identify individual customers for their analysis. But in some cases, you might just want to look at the cluster and see what's happening around those clusters, right? How is the cluster region doing it? Is there a risk of churn in that clustered customers, or is there any potential, or did we not send any materials at all to that particular cluster? So it is two-phase analysis. We could do the analysis based on the cluster, or we can further zoom in and drill down into individual customers. So this makes the things very easier, puts things into the visual perspective for territory-based analysis or the geographical perspective of the analysis. On to the next slide. So this is what I was saying, going into deeper, right? So in here, we have an account, we call it as a hospital, and we have different physicians associated to that hospital. And in that, you're seeing like we have on the right circle, you're seeing like number of orders you have received from that customer. And then it's an indicator as to how many relationships you do have at the bottom, indicated by double arrowed edge over there. So this is what you can now drill down to a particular HCP and see if that HCP is related to any other accounts as well, and identify what are the areas of influence you can potentially tap on. So this all puts into the perspective of and summarizes the power of the graph, but in a well-designed interactive web interfaces, so that not everybody has to now start learning writing queries in TigerGraph, do we? So on to the next slide. So you see, what really amazes me is that view on the right-hand side. Don't we all want to put our data together and perform an analysis and see what is all the connections we could infer out of it, right? And in this particular view, we could be looking at potentially any number of analytics. Like we could be looking at what really worked best, what really did not work best, what are the turnaround time clusters, is it region-based bottlenecks we are running into, right? Those are the deep insights we would be getting. And by storing the data in the way the graph does, often the analytics are way faster, because now we don't run into, we don't have a reason to organize our data which in related to the analytics which we are doing. Rather, we just go head on, get our use cases in, and data is already prepped. We start running our analysis. That makes our life much, much easier. And especially with the kind of things which we are trying to do, know your customer, You got to know everything is happening around your customer to know exactly where we are driving towards. Unless we do that, you can never really know your customer or his patterns, his um, likes and dislikes, I should say. If you're running a bakery, you would like to know your customer, what is he ordering, and you need to know his preferences, right? So that is as simple as that. So put everything into perspective around your customer to know your customer. Over here, we would like to use our current technology and build on top of it. And in here, we are utilizing Snowflake and our SQL systems and Vault on and make better. And the innovation is what we are driving for, better technology and make our lives easier and to provide much better insights. So on to the next slide. So off to you, Scott.
Thank you so much, Sharat. Yeah, what I'd like to do is talk a little bit about what Sharat pointed out so capably is that it's hard, right? This concept of patients and products and sort of the lineage of what doctors have been doing and how are they all connected, right? That's in itself a fairly highly connected hierarchy on its own. But then I start to see our K, Y, and the C is where did the clinic, what are the doctors and the patients, what are the risk factors, what is that secondary set? And what we see here now is we take a fairly straightforward hierarchy and start to see it in more 3 dimensions. It gets even more complex. And if I connect that to the previous hierarchy, it now gets even more complex. But then I see events and analysis and history. So now I need to do all of those things in the first 2 categories, but now I need to go back in time. I need to see how and what those outcomes were in the history in order to connect them in the present to make predictions about the future. And those 3 things alone make what Sharat seemed very straightforward, very, very complex. And so part of the project that we worked together on was to be able to make these connections, use the graph database in this way. And so now it starts to understand a little bit of why the complexity of what we were doing was a great fit for graph. Well, if you looked at what, again, sort of what Sharat pointed out was at the top, we want to create better outcomes, cross-sell and churn avoidance. Well, a lot of that with these lines over and the hard lines and the dotted lines over on the right, what we're trying to realize now is that though I may start with 1 or 2 seemingly unconnected use cases, they very quickly become very connected to each other. And our executives are over on the left. Ultimately, they want to, increase that revenue or market share or decrease the cost and make it more efficient. But always we're looking at risk. And so what we're showing in this is that graph, this is sort of a graph of the use case, if you will, allows us to now start with those, start to build. And as the complexity of that other data comes in, as we saw on the first slide, it starts to become interdependent and the graph starts to give us more and better outcomes as we move forward. The second item here, as Sharat mentioned, was most customers and most of you out there today have been doing machine learning. That's great. And what we're really aspiring to now is creating these data products that are scalable. How do you do that at scale? And as your data scales, as the users of the system scale, as those screens that we talked about, everyone is effectively touching that data in a very different way and they have different outcomes. But our goal with this kind of system was to create it in such a way that it gets better and it's very scalable in what we're doing and how people are interacting with it. Now, we heard, and you've probably heard from many of the other folks at the summit about what this intersection is. Well, what is it? Well, we're able to take those algorithms of betweenness or similarity or page rank and start to create now deterministic ways that humans can interpret that. And then how do we do things like advanced machine learning over on the right for these predictions and what we start to do. And it's this incredible sort of nexus of what that is. And then what Sharat showed us that we'll see here in a minute is the demonstration of how a layperson who may appreciate all of this, but not quite care so much that they just really need to make sure that a customer is happy, make sure that the opportunity and that customer is satisfied and in a more efficient way, right? That's really what this is getting to the heart of. And obviously TigerGraph was a core component of that, and why it was so incredibly important to simplify that is you have to have this capability at the base in order to create sort of the application that's so easy to use. Well, what does that really mean? Well, when we talk about dependencies, as Sharat clearly identified, was what happens if I don't get marketing material out on time, if a doctor doesn't start to participate or learn about a certain product? Well, those are the failure options. They are possibly good or bad, but finding that dependency in SQL-laden data is very, very difficult, which is why a simple representation, or in this case, that dependency is so incredibly important. Now that I have found it, maybe there are other mitigating circumstances or attributes that we can start to realize that are good or bad, that move us to the third one, which is similarity, which is if this group did an outcome that was positive, we'd like to do more of it. If they did a pattern that was perhaps not good, we'd like to intervene before it gets too far. How do we start to identify what those are? Then we can match those. Are there individual or atomic layers of elements that we need to get into that may take all of the previous ones now, and how do I categorize those? Again, I have to max sort of what's good, what's bad, create the labels that we saw in those user interfaces that now that human knows what to do and do it in a timely manner. Then we get down to flow. Where are those things going? What's the most efficient way? How do we want to do these things? Do I want to intervene now? Do I want to make a phone call? Is the age-old human contact something that we need to do? And that's really what this power or centrality is to allow now this sort of ad hoc search. We don't know what we're looking for, perhaps, and maybe all of these other patterns are brought to me. And this is really sort of the crux of why exact science, and specifically why a graph database, can sort of help this use case in specificity. Now, how does this all fit together? For those that are the technical folks that are out there today, many of those systems, we don't have to consume all of the data, so we don't need to rip and replace it. What we really want to do is connect to that data. We may move some of that data into our graph. We may be looking for certain connections, where they went, what their network was, a doctor, a patient, all of those different aspects. That allows us that flexibility now. As again, Sharat mentioned, we can bolt right in. We don't have to move all that data. We can save pointers in a graph database out to that other data, or we can move some of it in for more advanced analytics and those kinds of things. And then the last mile over on the right is how the human can now interrogate that graph and sort of leverage it at speed. And that's the other core component here, is taking millions of rows, years and years of data, and being able to do it in milliseconds is a pretty fantastic capability now that many folks are needing, not just sort of executives, but also sort of the analysts. Now, all of that sounds great, but let's see now the demo that we spoke about previously. So in this case, what I'm going to do is I'm going to ask Sharat to narrate over my shoulder here. We see now a very simple way to sort of jump in. Now, what we saw in the first version was the idea of a territory or a healthcare provider. In this case, I can just simply query it. It's going to now give me what looks like a standard list. Well, that's great. I can now drill in. I can see what that order looks like here. And now I can interact with it. Now notice, as Sharat mentioned previously, what these different categories were. Now, Sharat, you want to share with us some of the details that are in here?
Absolutely. So what we are looking at over here, as I mentioned before, right, we are looking at several of the swim lanes, and each of them are actually a different touch point, different ways we interact with our customers, right? And at the bottom is how the customer is interacting back with us, with this ordering pattern. And we could see that in that particular area of 2023, or at the beginning of 2023, no, 2020 Q3, sorry. There's really something made a difference, and which actually worked quite well. And it could maybe because of the effective marketing materials and the campaigns which we did. and something which really worked, and we would like to know what really worked over here, right? And then we would like to see, click on it and see when he actually attended and what are the emails he actually clicked on. And then it also gives us a flexibility to actually look at specific swim lanes. Maybe not everybody is interested in looking at email campaigns and speaker events. We have different permutations and combinations to have a very focused analytics, right? To come to a conclusion. So if you are clicking, go to the connections, then you can see what exactly is happening around this particular HCP. You see, we have a HCO, which is a healthcare organization associated to it. And then we have a territory which is associated to it. Clicking on it might give you a lot of other HCPs in the same territory. And then we have the option over here to show how many number of physicians in the view we want to see. And in here, we are looking at 10 or more of them, 10 of them. So let's see what it's going to look like now.
The other thing that we can do is, as we talked about up here, is we can go look at other kinds of categories. So now we can switch over to our territory map. All right, and in this next view, what we'd like to do now is let's start to look at these different regions, right? So what we'd like to do now is add multiple regions to this. We can see sort of our territory view. We can start to now lock in on what these different elements are. In this case, what I can do is I can go look in here, I can zoom in, I can see in this case, perhaps a clinic, and I can start to see some other elements here. From here, what I can do is I can actually just zoom in, and maybe I want to look at the churn detail that we talked about. In this case, what I'm doing is I'm just sort of showing what are the different attributes of that, right? And Sharat, as we look at this screen now, why don't you maybe sort of tell us sort of what we're seeing here?
So over here, what we are looking at is a healthcare organization and all of its associated HCPs. And you see, we have the little indicators over there as to the number of orders we are looking at and what's the average turnaround time. And we also look at like, how does it look like compared to the national averages of the entire product portfolio, right? So we have different indicators. You can see on the top hand right corner, the legend, which actually indicates different flags. So in this particular case, the red, we are looking at the TAT is lower than national average. So it looks like in 55 of the cases, the orders are slower than the national average. That would mean that we would have to drill down and see what actually is the bottleneck in the delivery. And again, this is all mock data, so I would believe this data, but this is a very nice representation of the view.
And so what we want to do here then is we're allowing these laypersons now to sort of see this in a different way. In this case, we can sort of lay it out in different patterns. And again, the simplicity here is really just let the human interact with this in a different way. Well, thank you so much, Sharat. I think the goal here was to give people just a quick taste. Obviously, your system does quite a bit more in what you do. And so that's really what we wanted to highlight there in the demonstration. So now let's talk a little bit about behind what are the kinds of things that you can do in these kinds of systems. And what we're doing now is exactly that. As we see over here on the right, Graph gives us the ability to do three-dimensional analysis. And so in the case that we saw there is maybe the blue is the extremely good, maybe the green is not so good, but fairly good, and red and now purple and then the light purple are now into sort of journeys, if you will, that we don't like. And we'd like to intervene in a positive way. Well, what did we do behind the scenes? Well, what we're able to do now is write those TigerGraph algorithms that come, if you will, in the box, where we can create now what those elements are and then create that sort of buckets, if you will, for good and bad. Those are called subgraphs. Now, all the new data coming in, so new output, new input, et cetera, we're able to quickly categorize those at speed and then create those buckets and then present those back to the user in a meaningful way. So what we've done now is we've taken that fairly complex kind of math or other kinds of elements, and what we've been able to do now is surface it in, number one, a fast way, and then number two is put it in a pleasing visual. Now, why does this start to make sense? Well, all of us that use Netflix and Amazon in the COVID times, which is all of us, what have they been doing? Well, they've been really sort of building these graphs for many, many years. And what are they really doing behind the scenes? They're using effectively this graph to try and figure out what is it when I buy that's similar to what Sharat would buy, and then what is it that we can start to recommend. It's this similarity capability, and now this recommendation that we're starting to utilize. This now allows us to look at what we did yesterday and then start to realize that if red and blue cars are chosen in this sort of cartoon, that what happens then is if Scott's about to pick or use a different doctor, or in this case, a green and a red car, I can start to predict with high accuracy what is it that will happen next. And again, that could be a good or a bad pattern. And that's what we're really trying to do. Now, there's more to it, right? So we can take all of the different elements, the different attributes for your business, like we did for Exact Sciences, and we start to then put that into a more deterministic graph algorithm where we can start to do that. Now, when we see this course correction, we can find similarity or linkages in time in the graph. And what we're doing now is, in this case, we can sort of make that recommendation so that we can create a positive interaction. And in this case, again, in this sort of cartoon, if I know what's going on today and I have many sort of patterns that I have seen before, I can now, in this case, effectively predict that somebody in Fran's journey, in this case, can start to recommend other products, or there's a high likelihood that they're going to do other things. Now, how does that apply in our use case here? Again, it could be a care path, it could be a deterministic outcome, and again, as Sharat mentioned, it could be a sales pattern for a doctor or someone else. But again, these are the concepts that we're using behind the scenes. How do we start to realize now these cohort patterns? In this case, we start to see that there are groups of people and what these domains look like. That's what that picture we showed, and that Sharat showed as well in that first picture, is those colors or categories of different elements. Now, your data model in TigerGraph will determine what these features, if you will, or what the model inside of TigerGraph looks like. But the concept is very simple. We start to use those to create out which ones perhaps are more effective for marketing or outcomes around this. And again, these patterns are sort of ubiquitous in how we use the technology behind the scenes. Again, here we see what that really looks like. Over on the left, I could see perhaps a doctor or a patient's outcome, which is, it's very similar in other ways. And I can see what those cohorts and I can see what those connected elements are. Now, again, this is very, very sort of non-visual for our users, but this is what's really going on under the covers for such a beautiful application that Sharat's team has in their screen. And what we're doing now is we're able to bring this sort of AI up to the surface. And again, how do we do that? When Sharat mentioned the sort of the different campaigns, you can start to run those and look for those patterns. They look simplistic, but we're really sort of belying now this complexity that's inside of TigerGraph. Ultimately, what that means then is in that screen that he mentioned, now a human can just simply say, how do I? What should I do? What are the outcomes? What have I seen in the past? In this case, again, this is not a real one, but if I wanted to offer them a gift card, so maybe there's some sort of tie-in for what is an outcome, or I could do nothing, or in many times I could see what a scheduled phone call is. So for many of the folks out there, right, these are the different ways that you want to interact with your customer. And again, these are not real, but making a phone call, doing nothing, and then doing something are always part of what you want to look at in this style of a system. And now we have the real power to understand what is the cost for us to do one of those activities. What is the negative cost if I lose that customer, if I don't do anything, right? And so what we're able to do now is bring it together in this very simple visual package that the human can now make that interaction. With that, thank you for joining us. We hope this was informative, and really what we wanted to bring across here was that, you know, the technology and what the human can bring are all sort of part of this. And again, thank you so much for attending.